Good morning, 12th class. Today our topic is Hoff factor and extent of dissociation or association in an electrolytic solution. As I told you, that Hoff factor is helpful in knowing the extent of dissociation or association in an electrolytic solution. So how it helps? For that also we have a formula, okay, and on that basis we have numericals also, okay, and this is our last topic of this chapter. Okay, now first of all, just see, you have to understand what is degree of dissociation, because we are talking about dissociation or association. The actually degree of dissociation, that one is represented by alpha. This one is representation, so that one is represented by alpha, okay. And simple degree of dissociation, it's a number of moles of the substance dissociated, kitne टूटे हैं, upon total number of moles of the substance taken, okay. That one is degree of dissociation, and that is represented by alpha, okay. Now in this, our concern is with formula, no derivation. Although it's given, explanation is also given but not required. I'll explain for dissociation, okay, but only you have to learn formula. Now just see, in this one it's a simple formula of degree of dissociation. Now suppose a molecule of an electrolyte gives M ions after dissociation. This one you can take it as N, X, Y. It's totally your wish. I am taking it as M. Okay, you can take it as N also. Okay, small n. Now electrolyte gives M ions after dissociation. Okay, now just see, in this one, number of moles of solute left undissociated. Okay, suppose total number of moles we are taking, it's a 1. Okay, the undissociated means jitne nahi hai, to 1 minus alpha, whatever is dissociated. The number of moles of ions formed or bane kitne, that one is M alpha. Now just see, total number of moles of particle, so what is the total number of particle, it's a 1 minus alpha plus m x. This one is total number of particles. Now we have formula for I, that is I is equal to observed number of moles of solute upon normal number of moles of solute. So what about our observed one? It's a 1 minus alpha plus m, this one is alpha, it's a degree of dissociation, upon 1, this one is total. Now after solving this, okay, now this one is 1 minus alpha plus a, because 1 obviously it remains same. This one is 1 minus alpha plus m alpha. Now after this one, that your formula is, after solving this, your formula is alpha is equal to I minus 1 upon m minus 1. Now your main concern is with this only. It's alpha is equal to 1 I minus 1 upon m minus 1, where m is equal to, it's a simple, how many ions are dissociated in the solution. Okay, you can take very general example. Now suppose, okay, suppose this one is NaCl. Okay, now after dissociation it gives Na positive plus Cl negative. Okay, now just see, in this one, that previously in starting, okay, their concentration is 1, matlab number of particle is 1 or molecule is 1. After dissociation, and this time, okay, when dissociation is not a start, only it's a NaCl, means you can say at initial state, we have learned in equilibrium, at initial state the concentration is full on reactant side and product it is, okay, 0 0. The same condition when reaction not started, to this side full concentration, and here it is 0 0. So here number of NaCl is full. Now when dissociation start, number of particles started dissociating, so this one is 1 minus alpha. Now just see, this one is degree of dissociation, whatever is the dissociation part this side, formation on that side, so it's a alpha and this one is alpha. Okay, so alpha because this one is dissociated, and here number of ion is 1, so alpha is multiplied by 1, this one is also multiplied by 1. This one is basically what, that is m is represents what, after, in this one if you want to calculate m, so m is 1 plus 1, it's a 2. So your number, whatever is the number of ions after dissociation, so after dissociation number of ion is 2. So accordingly you have to calculate. Okay, so this formula you have to use, that is I alpha is equal to I minus 1 upon m minus 1. That is for dissociation. Now second one we have, that is the degree of association, means how much particle in an electrolytic solution it get associated. So previously number was more, after association it was less. Okay, so for that again we have degree of association, that one is also represented by alpha. Okay, now the number of moles of the substance associated, so instead of dissociated we are writing it's associated upon total number of moles of substance taken. Okay, this one. And for association we have formula alpha is equal to I minus 1 upon n minus 1. Here I am taking number of dissociation as n. Okay, why? Because keep it in mind, this one is for association and m is for dissociation. You can take n for both association as well as for dissociation, but you have to learn both the formulas. Now this one is for association. Now on this basis, okay, we have recent year question, abhi 2020 में आ रखा है, it's a board question. Okay, so I'll explain that also. Now just see. Okay, now this one is 2020 question. Now a 0.01 m aqueous solution of aluminium chloride freezes at minus 0.0868 degrees Celsius. Calculate the percentage of dissociation. Simple. You know degree of dissociation, how to calculate? Percentage means multiply by 100. Same condition. Okay, given Kf for water is given to you. Now you have to calculate alpha. Okay, for calculating alpha, I is required. Okay, as well as m is also required, ki number of ions dissociated, okay, after dissolution, so that one is also required. Now just see in this one, simple molality is given, temperature is given. So with the help of this formula, delta Tf is equal to I into Kf into m, we can calculate I easily, whatever is given to you. Now write down. Okay, now one point is very important, 12th class. Now just see in this one, delta Tf. Okay, this one is already given to you. No need to convert it into Kelvin. इस बार भी बच्चों ने पेपर में बहुत, ठीक है, बच्चों ने क्या कर रखा था, convert this into Kelvin, and then answer is wrong because difference is always same. Either it is given in Kelvin or either it is given in degree Celsius. So no need to convert. Keep it in mind. Okay, now this one is same. Okay, now molality is given to you, Kf is given. Okay, that one is it now 1.86. It's a Kelvin kg per mole. Okay, it's a Kelvin kg per mole. Done. Now put values. Okay, I this one is 0.068 is equal to I into 1.86 into 0.01. Now just see. Okay, put values here. After solving this, okay, after solving this, your I is 3.65. Obviously you have to solve. Okay, now this one is answer is 3.65. Now second thing is, now I is with you. For calculating alpha, you should know m. Okay, so for that our equation is with us. Now this one is aluminium chloride. You know aluminium chloride previously full percentage, or either you can say it's a full molecule before reaction. Okay, after reaction it dissociated into aluminium 3 positive plus 3 Cl negative, 1 of aluminium and 3 atom of 3 ions of chlorine. So after dissociation 1 alpha, and here alpha but multiply by 3 because 3 ions of chlorine. So total number of m is equal to 4. 3 plus 1 4. Now simple formula, alpha is equal to I minus 1 upon m minus 1. Okay, put values, it's a 3.65 minus 1 upon 4. Don't get confused over here, you have to add both the ions. Okay, so it's a 4 minus 1. Now after solving this, your answer is 0.883. It's a 333 actually. Okay, now for percentage, so you have to calculate percentage dissociation, degree of dissociation, percentage. Okay, so multiply this term with 100, so it's 88.3%. Okay, thank you.